Hello, my amazing students. This is Mrs. A with more on 5.1 Intermediate Algebra, and we are talking about elimination. So this 5.1 I'm breaking up into probably 4 sections. This one is elimination, part C. And the first one we're going to start with is one that is just, you don't have to do anything to it in order to eliminate. Okay, so this system of equations, two linear equations, is already set up for elimination. When we are using the elimination method, we would like to have two equations that are in the same form. Generally, standard form is the one that we usually see them in, and it works wonderfully with elimination. So here we have our x's plus our y's is equal to our constant. So both of these equations are in standard form, except what? We don't usually have a negative there on the x term, but it's close enough for right now because this is exactly what we have to do to two equations to get them ready to eliminate, and that is to have one of the variables exactly the same with the opposite sign. So that's our goal in getting it ready to eliminate. And so since we already have them in that form, let's go ahead and add the two equations together. So we have a negative x and an x, which will cancel each other out, leaving us with a 4y is equal to 12. Okay, so 4y is equal to 12 is what I get when I add the two equations together. So now you'll notice I have one equation in one unknown, and if I divide by 4 on both sides, then I get y is equal to 3. Okay, so I've solved for one of my two variables. So now I'm going to take my y is equal to 3 back into one of my equations. Well, I'm going to plug my y is equal to 3 right here into this first equation. Okay, I'm going to bring my negative x back for a little bit, so take away the little cross out symbol here. Okay, so we're going to bring back our negative x. Negative x plus y is 4. Negative x plus 3 is 4. So let's get our negative x by itself. So negative x will subtract a 3 from both sides, and we'll get negative x is 1. Or x is negative 1. Remember, we never want to leave it solved for negative x. That's not finished. We want x, not negative x. So in order to get from there to there, we're going to multiply both sides by a negative 1 to get x equals negative 1. All right? So we have solved for x, and we have solved for y. Now, I just used this top equation to plug in the 3 to get the x value out. So I will use the other equation that I didn't just use, and I will check both the x and the y in there. So the x was negative 1, so we'll plug in a negative 1 right here for the x. We'll plug in a 3 right here for the y. So we have a 3 times a 3, which is a 9. Take away a 1, which is an 8. And that's what it's supposed to equal. So the solution is the point negative 1, 3, and this one is a 1-point solution. So this is a what? Consistent independent system with a 1 solution point. And this is solving by elimination. Now, it's not always quite this simple to where it's already set up to eliminate a variable. Sometimes we have to work at it a little bit. So we're going to give you quite a few more examples. In this system, we have plus y and plus y. If we want to get rid of our y's, we would need one of them to be a minus y. So we could either subtract the two equations, or we could multiply one by a negative 1 and do it that way. So let's just multiply this one up here by a negative 1 all the way across the equation. So I really should do this, right? Because we're going to multiply negative 1 all the way across, and we're going to just change the signs. Negative x and negative y equals negative 3. So this is not a division sign here. So I'm done with this one because I just multiplied it and I have it down here again. So now if I add these two equations together, I've got a positive y and a negative y that will cancel out. So I'm going to end up with 4x plus a negative x is a 3x. My y's go out, and I get a 6 plus a negative 3, which is a 3. And if I divide both sides by 3, then I get x is 1. Okay, so now I have 1/2 of my point because I have the x coordinate of my point. So I'm going to go back up to one of the equations. Okay, I can use this original one that I had. We'll just take the negative 1 off of there. So x plus y is 3. So if x is 1, then 1 plus what is 3? And the answer is 2. So we say y is 2. All right, so we just plugged it into one of our equations. But we should check our point. So let's go into the second one that I didn't just use to find the value of y. Let's go into this equation right here. That's a little asterisk. Okay, and we're going to plug in x is 1. So right here, I'm going to plug in a little 1, and y is 2. So right here, I'm going to plug in a little 2. And we have 1 times 4 is 4, plus 2 is 6, and that is true. Verifying that our point, which is 1, 2, x is 1, y is 2, or the ordered pair 1, 2, is our solution point. So we're going to come back. Those are two pretty simple ones. Now we're going to come back with one that's a little harder. All right, this system is a little bit more complicated because it is not even in the right form to eliminate. Remember, we want both of our equations in the same form. Since we already have one in standard form, we're going to change this one into standard form, which means I need to take this 5x, it's a negative 5x, so I'm going to add a 5x to both sides, so plus 5x, and over here plus 5x. Okay, so now I'm going to bring this new equation down here, and I'm going to have 5x plus 2y, and here my negative 5x and my positive 5x will cancel out, and I'll be left with a 2. Okay, so now I have gotten both of my equations to be already in standard form, so they're in standard form, and I got a problem because there's not a single constant that I can multiply by to get both x's or both y's to cancel out. Okay, in other words, there's nothing I can multiply 2 by to get a 5, and there's nothing I can multiply 2 by to get a 3. They're not multiples of each other. I'm going to have to multiply both equations by something. Okay, now the least common multiple between a 2 and a 5 is a 10. So I could multiply by 5 on the top and negative 2 on the bottom to get both of the x's to go to 10 and negative 10. Or my y's, I could multiply to get a 6 and a negative 6. So let's go with the y's. Okay, so basically I'm going to erase this little arrow because it's a little confusing. I'm going to cross out this line because we just redid it down here. And now I'm going to multiply this whole equation all the way across, and this whole equation all the way across by a constant to get rid of my y's. So since 3 and 2 both go into 6, I'm aiming for a 6y and a negative 6y. So we're going to multiply this one to get a 6y. So I'm going to multiply out here by a 2. And I'm going to multiply this one to get a negative 6y. So that means I'm going to multiply by a negative 3 all the way across the equation. Remember, this is our multiplication property of equality, which says that we can take any equation and multiply both sides by any constant that's not 0. Okay? So we're going to multiply the top one by 2 to get 4x and 6y and a negative 16 on the other side. We're going to take our second equation and multiply by a negative 3 all the way across. Negative 3 times 5 is negative 15x. Negative 3 times 2y is negative 6y. Negative 3 times 2 is negative 6. So the important thing to note is that once you decide what number you're going to multiply by, you multiply each and every term by that number with the goal of getting one of your variables to cancel out or eliminate. So now you can see that my 6y and my negative 6y are all ready to cancel if I just add these two equations together. All right, so I have a negative 16 plus a negative 6 is a negative 22. And I have a negative 11x. My y's cancel out. So I get a negative 11x is a negative 22, or x is 2 when I divide both left and right by a negative 11. Okay, so x is 2, 1/2 of my solution point. So now I'm going to take the x is 2 and I'm going to plug it back into one or the other of the original lines. Okay, so let's go back to this first line, and I'm only dealing with this original part here. Okay, not this one that I multiplied by. So we're plugging in x is 2. So we'll plug in an x is 2 right here. So we've got 2 times 2 is 4, plus 3y is negative 8. So if we have a 4 plus 3y is negative 8, okay, and we subtract a 4 from both sides, then we get 3y. Let's subtract the 4 and subtract the 4. So now it's a negative 12. 3y is negative 12, or y is negative 4. So I'm going to put that down here. Y is negative 4, the second part of my solution point. So I got the y is negative 4 by plugging my x into this equation. Therefore, let me erase my little multiple here. I'm going to take this second equation and I'm going to plug in both points, x and y, to check, to make sure I have the right solution point. So x was 2, so I'm going to put a little 2 in there for the x. Y was negative 4, so I'll put a little negative 4 in to this equation that we didn't just use. And we get 10, take away 8 is 2. And that's true. So we have verified that our point works. So in this problem, this was elimination, but we had to ready it for elimination because we did not have either one of our variables that would cancel right away, and we needed to end up multiplying both equations by something in order to get a 6y and a negative 6y so that they would cancel. Okay? So I'll hold your board off a little bit there, so if you want to see the whole thing, you can. Be back with an even more complicated problem next. All right, now you will have problems just like this. Fractions. All right, when we have equations with fractions, one of the quickest ways to get rid of these bad boys is to multiply by a least common denominator. Okay, so if you look at the first equation here, my least common denominator is 6. It is the smallest number that both 2, 3, and 6 will go into, is 6. So you can see I'm going to multiply by the least common denominator. I'm going to take this equation and multiply the whole thing by 6, which I can do, and we can think of that as 6 over 1. The multiplication property of equality lets me do that. Multiply the left and the right side, every term, by 6. Okay? When I do that, I get 6 over 2, which is 3, x. I get 2/3 of 6 is 4, but there's a negative there, so it's a negative 4y. And 6 times a negative 7/6 is just negative 7. So I have taken this equation, multiplied it by 6, and now I have gotten this equation right here. Okay? So I cleared up one of my equations. So now I'm going to go down here to this second equation. I'm going to clean that thing up. Okay? 4, 2, and 8 all go into 8. So I'm going to multiply this whole thing by 8 over 1. Okay? 8 over 1, or 8, all the way across. Okay? So 8 divided by 4 is 2x, and there's my 2x right there. And negative 1/2 y times 8 is negative 4y, and there's my negative 4y. And 8 times a negative 3/8 is negative 3, and there's my negative 3 right there. Okay, so I have this equation is my second equation after I clear out all the fractions. Now, if you look at those two equations now, they're not so far from elimination form, are they? I have a 4y and a 4y. It would be so cool if I had a 4y and a negative 4y, because then they would eliminate. So what I did is I took this second equation here and I multiplied the whole thing by a negative 1. So I got negative 2x. It's just going to change each one of the signs. So now this equation is the one that I'm going to use instead of this equation, because they are equivalent equations. I just multiplied one by a negative 1. So now look what happens. I've got a 3x minus a 2x. When I add these together, 3x and a negative 2x is an x. My y's cancel, and I get a negative 7 plus a 3 is a negative 4. So I wind up with an x is negative 4. So I have one of my variables. So here we have x is negative 4. So now I have gone back to my original equations. Okay, you don't have to. You can go back to the one that you've already simplified. You could have made a mistake in simplifying your equations. So it's probably best policy to go back to your original, but honestly, a lot of times I go back to my one that has the whole numbers instead of the fractions. But I'm going back to one of my equations, okay? And this one was originally the first equation, okay? 1/2, this is where my x was, so I'm going to plug in the negative 4, minus 2/3 y is negative 7/6. That was my first equation, and now I'm plugging in my x value. Okay, negative 4 times 1/2 is negative 2. Okay, negative 2 is the same thing as negative 2/1, minus 2/3 y, and negative 7/6. Okay, now, I got tired of dragging those fractions around. I just decided to multiply everything in this equation by a 6, just to clean it up. So I multiplied everything by a 6, or a 6/1. And when I did, I got a negative 12. And 2/3 of 6 is 4, so that's a negative 4y. And a negative 7. And then if I add 12 and add 12 to both sides, I get a negative 4y is 5. And when I divide by negative 4 on both sides, I get a y is negative 5/4. Okay, so now I have 2 points. I have my x and my y. My x here is x is negative 4, and my y is negative 5/4. Okay, so now I used this top equation to substitute in my x to find my y. So now I will use the other equation to check both of these values. Okay, so here's my check. Okay, I took the second equation, which started with 1/4 x, and I plugged in both the x and the y values. I checked it, and lo and behold, it worked. Therefore, since both of my solutions worked in the other equation, I knew that I had correctly solved, and the 1-point solution was negative 4, negative 5/4. Back in a minute with some more.